We are Group 3 and today we're going to be analyzing the insurance dataset. First, we import the pandas and load the dataset using the read function, which stores the dataset as the data frame, and we check the size using shape, which tells us the number of rows and columns. We then use the head function to view the first few rows. This helps us quickly understand the structure of our data frame and spot issues such as numerical values being written as text. We then use describe to generate summary statistics for numeric columns. We reset the index for clear row labeling, and we finally use info to examine data types, missing values, and memory usage. Lastly, columns shows all column names, helping us reference variables correctly during analysis.
Now welcome to clean data process. We started clean process by first of all importing pandas, then we decided to convert BMI and blood pressure columns from strings to flows, specifically replacing commas with dots to ensure that they are readable as numbers. After that, we insert the data integrity and we remove all duplicate rows and drop any missing values. Finally, we filter out outliers, keeping BMI at 55 and blood pressure at 150 because we had outliers equals, for example, BMI 22,000, which was of course not correct, and we decided to make this filter. And we reset the index for a fresh start. Then we decided to validate, do we have any outliers, duplicates, or null values. We conduct the analysis. As you might see, we have duplicated sum equals 0, and also we don't have any missing values. And finally, we decided to conclude a dataset summary to understand how many rows we have and how many columns. We ended up having 946 rows and 10 columns, and most importantly, our maximum values for BMI and blood pressure now sit at 53.13 and 141.5 respectively, confirming that our outlier filters were applied correctly. The data now is clean, and we can move on to graph analysis of the dataset to 5 most important graphs.
Insurance charges by smoking status. This graph explains the strongest driver of insurance costs. It clearly shows a large gap in both average charges and variability between smokers and non-smokers, which dominates most other effects in the data set. Distribution of insurance charges. This graph summarizes the overall cost structures. It shows that charges are heavily right-skewed, with most individuals having low costs and small groups generating extreme expenses. This context is crucial for interpreting all subgroups comparisons. Correlation heat map. It compresses multivariate relationships into one view. It shows which variables meaningfully relate to charges and each other, while also highlighting that many variables have weak correlations, reinforcing which factors matter most. Correlation between BMI and charges provides the clearest visual of how a continuous health factor relates to cost, showing a weak to moderate positive trend with largest dispersion. Insurance charge by age shows how charges evolve across age, capturing the general upward tendency and variability that age introduces into insurance costs.
Next step, in step 6, we perform the analysis using core pandas functions like value counts, group by, describe, and pivot table to summarize relationship between the columns. First, we use value counts to check distributions. Most people are non-smokers with 9,999 no and 261 yes. Then with group by and describe, we compare medical charges by smoker status and saw a clear difference. Smokers have a much higher average charge, about 1,000,004 versus 0.41 billion for non-smokers. For activity level, value counts showed most users a high or very high activity, and our pivot table summarized BMI across levels to check whether lower activity is linked to higher BMI. For blood pressure, we use group by and pivot table on blood pressure and charges to compare mean and median costs, noting many unique blood pressure values with small counts. Finally, we created age groups with cuts, then used describe and pivot table on steps per day, showing younger groups average slight more daily steps than older groups.
Our team was tasked with analyzing a dataset of 10 variables, including demographics like age, region, and health metrics like BMI and blood pressure, to understand what actually drives insurance costs. First, we found that lifestyle is an ultimate predictor. Our analysis of the smoker variable shows that smokers force significantly higher median charges and more frequent extreme cost spikes than non-smokers. Secondly, geography matters. The Southeast region stands out for having both the highest median insurance charges and the largest population of smokers, suggesting a strong link between regional habits and financial risk. Third, health metrics are deeply interconnected. Our correlation heat map shows a strong correlation between BMI and blood pressure. As these numbers rise, our scatter plot shows the ceiling for potential medical charges rises with them. Finally, we discovered that sex is a neutral factor. Despite being a key categorical variable, our data shows the median charges for males and females are nearly identical, proving health habits outweigh gender in the dataset. By examining these specific variables, we've moved beyond simple demographics to show that insurance risk is primarily driven by measurable health indicators and lifestyle choices.
First, look at smoking status. The difference is huge. Smokers account for a much larger share of total cost than non-smokers, making smoking the strongest risk factor in the dataset. Next, BMI and blood pressure show a clear positive relationship with the charges. As BMI and blood pressure increase, insurance costs rise as well, confirming how lifestyle and cardiometabolic health translate directly into money. Age also matters. Charges steadily increase with age, but the effect is weaker than smoking or BMI. Physical activity, measured by steps per day and activity level, helps explain some variation, but not as strongly. And finally, some variables are much less informative, such as gender, region, and the number of children, which only show minor differences in the average charges. And so for pricing prevention, the focus should be on smoking, BMI, blood pressure, and age. These are the key levers for both insurers and policyholders.